I'll start in a couple minutes. I'm waiting for students. Next time, at time 31, I close door and you left without attendance. Two minutes pass. Strange, I had a viewer online. Okay, let's go. You are from electronics program? No one from mechatronics or something like this? Only electronics? Okay. Generally, this course is for power engineering. I hope it will work. Some, maybe in some part will, I don't know, they are for power engineering students, and I rely on knowledge on electrotechnics theory. Seriously, if you don't know electrotechnics, you will get problems here. Okay. So, now, favorite question of all students: what should I do to get my grade? I have published, they were published 4 tasks. You need to complete them till the end of week 20. Would be bad to make all, but if you just need to pass, complete 1, it will be enough. Okay, next. Next, what's next? What's all about? What's in your schedule? Theory of signals. actually basics. Yeah? Yeah. If you, I'm also sending you signals. If you don't understand, I knew we have a different view on English. I thought what I should mimic guys from British Broadcasting Corporation in mid-80s, their pronunciation. Yeah. As you understand, it's a bit different from your view. If you don't understand something, raise your hand. Oh, I don't understand. Good? Good. Now, also raise your hand if you have feeling that I speak German. It may happen. It may happen what I can speak Latvian without translation. Again, raise hand, or we don't understand. Now, what this course is about? What are you doing here? Theory of signals. Okay, theory is something blah 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 blah. What is signal? What I'm talking about? If you can observe any physical value in time, I will write multiple times. Signal as a function of time. It can be voltage, it can be current, it can be, I don't know, pressure, anything. Anything observable in time and measurable can be a signal. Yes, we apply, in general, theory of signal is close to the communication area, but we use it in power engineering. And for you, for your understanding, you have basics of electrotechnics, yeah? Yeah. You have theory of circuits. You have theory of circuits. After this course, actual theory of signals is what follows circuits theory. In the, how to say, electrotechnics, electrical sciences, basic level is DC currents, then AC, then circuits theory. After circuits theory goes theory of signal, and the last one is common electromagnetic field theory. But I don't think you will take this course.
Actually, I take it.
No, you're taking field and magnetic circuits. It's a basic level. Believe me, there is 1 year, complete year, course of true field theory. It's very, how to say, complex thing. If you would like to take to the highest level possible, quantum magnetodynamics. But believe me, it's not the easiest thing on this earth. To my knowledge, from who learned it, approximately 10% needs mental help because of total mental devastation. Okay, now we are in theory of signals. So theory of signals is a next level after theory of circuits, and signal can be voltage, current, anything what can be observed in time. When I say what my signal is determined, this means what I have mass, exact mass description for any time starting from minus infinity ending to plus infinity. So for any time moment in existence of this world, I have exact mass description. That's what means determined signal. What means non-determined? Probabilistic. In case of probabilistic signals or stochastic signals, I can only speak, let's say it's possible magnitude of my signal, distribution curve. Here will be probability. probable this, probable that. Operation with probabilistic signal, calculus, are not so easy. In our business, it's a general approach to substitute probabilistic signal with ideal determined signal. Or taking most probable. It's a good approach, but not good enough. Good approach is to substitute probabilistic signal with ideal determined and selected in such a way to ensure system operational in any possible condition. What does it mean? In my case, power system protection, I need to guarantee that my device will be operational during, say, expected system fault. This means what my device, if it operates by current, should withstand, if my rated current is 5 amps, it should withstand 200 amps within 5 seconds. After that it can burn. But I need to ensure operation at maximum possible current 200 amps within 5 seconds. Here is my test signal. If my device is operational at 200 amps, it will be operational in any case. So we select max possible and substitute probabilistic signal with determined signal ensuring operation. Next idea about signal. I can have continuous signals and signals of discrete time. What means continuity? Let's say my time, 1 year can be split in months, yeah? Each month can be a day, day in hour, hour in minute, minute in second, second in millisecond. Every millisecond can be divided in nanoseconds and so on. Our time is continuous. Now, let's say I had some, this was a signal. Signal in time. Continuous signal in time. So, continuous signal in time. I took one student, one happy student. I supplied him this voltmeter and asked, can you please observe the signal? What will I get? I will get a table. Something like 1, 2, 3. Number, time in minutes, for example. 1, 2, 3, 4. And voltage, I don't know, 3, 5, 7. My student performed and so on and so on. Performed measurements. What can we tell? Let's say this is number 1, this is number 2, this one is number 3. This one corresponds, okay, 3 minutes. Here are my measurement points. Okay, my students' measurement point. My students give me, here, professor, your signal measure. What was signal, let's say at this point, I can input 2.5 minutes. What was signal level at this point? Who knows? Not measured. Maybe like this, and maybe some spike. We don't know, not measured. So, original signal was continuous, but after it was represented as a table of value, this table represents what? Time, discrete time signal. If we have, for example, time space between measurements tau, red values represent signal as a set of discrete values I time, where I is integer value. Discrete time. Any ideas why do I speak about discrete time signals? Our time is continuous. Machine, any digital system operates in discrete time. Digital time is discrete. And there are known, not known, known, not known, known, not known, not measured, not zero, not anything, unknown. Known, unknown, known, unknown, known, unknown. Discrete time signals are characterized with, how to say, known, not unknown, not measured. Our time continuous, machine, computer, ordinateur if you like, time is discrete. If we do like to perform numerical processing of signal, we should be ready for discrete time operation. Okay, let's go forward. Go forward, go forward. Where should we go forward? More. Signals are periodic and aperiodic or non-periodic. What means periodic or non-periodic? If my signal repeats in such way equals to plus. So if my signal repeats after period t capital, here integer, m is integer, m can be from minus infinity, 0, 1, infinity. If signal repeats, it's a periodic signal. We like periodic signals because for stable regimes, for stationary regime, it's enough to calculate within time frame of one period. Since signal repeats, calculus results will be, how to say, propagated or can be extrapolated for whole signal. We need to perform calculus only on one frame of period. Periodic signal. What means aperiodic? Or non-periodic. Simple circuit. Okay, here will be ground. switch is turned at time moment t equals to 0. What will we see at the circuit output? Any ideas?
So can you repeat the question again?
What will we see here at circuit output when switch is flipped over?
Flipped off.
Yeah,
I suppose there won't be anything.
anything.
No, I don't know.
Anything. No. Before switch is turned, this part is not energized. All energy will be sucked by resistance. So before T0 we will see nothing, 0. After this capacitor charged up to E potential will discharge in 100% sure way. It will be E a power of here we can write alpha 1 divided by x. That's what we will see. Discharge of capacitor. Pulse is one clear pulse. This signal is continuous. Yeah, it's determined 100%. Repeats? No. Here, clear example of non-periodic signal. Never repeats. I can do a trick. I can take pulse generator producing signal like 1010 with a period of t capital. Yeah, this I can take this one. What will I see if I use its signal to drive my switch?
You'll be periodic, I suppose.
Yeah, it will be periodic. I will see discharge, charge, discharge, charge, something like this. Pulse sequence. It will be sequence of pulse with period t capital set by my driver. Pulse sequence. Pulse sequence looks like nice periodic signal, but it's an artificial created with computation. Here is point of interruption. We can consider it periodic. It is periodic, but we need to be careful because it's artificial created. We can see some side effects. Okay, more signal ideas. In our business, we like signals of special form, like let's say S cosine something like this, or like this. I can write S max cosine omega time, where omega angular frequency is double P divided by period. Period S max. Signals like this, we like them. Ideal voltage. In case of ideal voltage, it will be 20 milliseconds, and this one, if we can net voltage, should be 311 volts. Nice sinusoidal voltage. This kind of signals are called harmonic. Pure sound. Idea of pure sound. Oh, nice, nice. Idea of pure sound. Idea of pure sound corresponds to this formula. Harmonic signals. We love harmonic signals. I will show why we love harmonic signals. Harmonic signals are nice. Next, more ideas. Let's say I have nice harmonic signal. This one is period. Repeating time. Angular frequency measurable in radians per second. Known? Known. Frequency in hertz 1 divided by. There are two frequencies and one period. And what's the name for this value? Magnitude. I can use also amplitude. In Latvian, amplitude. It's a magnitude of signal. This one is magnitude. Let's go forward. And what forward? I need one more idea. It's idea of effective value. What means effective value? I need way to compare signals. I can compare them in frequency. I can compare in magnitude. And I can compare in energy. Idea. Let's say we have resistance of N and my signal powering it. Heat power will be P1. Okay? If you attach voltage to resistance, it becomes hot. I can do what? I can take same resistance, attach it to DC source, and of course it will be hot, it will produce thermal power P2. Dissipate. So I can say that if P1 equals to P2, E is a kind of value or weight for my signal. Is it reasonable? In meaning of energy. If they produce as much heat energy as one another, they are equal in terms of resistance heating. Understand? What will be what will I see on this side? P2 equals to E multiplied by current, or multiplied by R divided by R, so E square 100% clear. Now, what about the second one? Actually, first, P1. What about P1? Power 1 as an instant power in any time moment will be square of my signal magnitude at this time divided by R. Same way as I got it for DC. I assume simple case what? My signal is a periodic signal. 0, 1, 2, blah, blah, infinity. What my signal is a periodic signal. If I limit myself in periodic signal, because another way I should calculate for infinite time. In case of periodic signal, I need to take into account only one period. This means what total energy or double will be sum of all instant powers. 1 divided by 0 to time S squared. This one, this W is amount of energy heating my resistor within one period. Now, question from physics. What's written here? Watt meter. What this device measures? Power in watts. And what is 1 watt? If something produces 1 joule of energy within 1 second, it will be 1 watt. Yeah? Yes. We have double joules of energy within 1 period of time. What will be power in watts? P1 in watts will be W divided by time. Joules in second. Huh? So now I'm writing what I'm writing. I'm writing E squared divided by R equals to 1 divided by PR integrating from 0 to time S squared. That's what I'm writing. Because P1 equals to P2. This one goes. E should be equal to 1 divided by period, integrating from 0 to period, S squared of time. This is called signal effective value. It's a DC source producing as much energy as this signal within a period. What meaning of effective? Do you know this voltage effective? Something not familiar. And what about RMS? Root mean square. RMS value, if you, where is meter? there should be somewhere material written RMS, true RMS. RMS value is same with effective value. Again, it's a DC source producing as much energy as our signal. RMS values are good for electrotechnics. It's easier to analyze networks in general, not in instant values. Okay, go forward. For harmonic signals, for signals like as cosine, RMS equals to M magnitude or amplitude divided by square root of 2. It's for harmonic signals. Not for anyone. But for harmonic signals. Now my next toy. Abus divus vajag?
Nu, ja tev ir plusā simtnieks vai kā nulliens, astotnieks vai...
Nē, man ir tikai tev vajag arī pirmo numuru, vai man tev laikam...
Nē, es no maza diametra, no 7,9. Tur es domāju, ar pirmo es varu palaist. Ap 4 atnākšu.
Jā.
Man gan 4:10 jāiziet uz vilcienu.
Nē, nu bišķiņ pirms es pabeigšu ātrāk.
Davai,
Man šodien tāda tēma. No, I can't help. So, what's going on now? This nice box. Can switch myself. Maybe. Come on. Stand here. Okay. It's a source of test signals. I can get variety of signals for my demonstration and experiments from this old device. Now it's connected to the acoustic amplifier and we can hear. It produces harmonic signal. What do I change? Frequency. Frequency decreases. Now I'm changing magnitude. get the signal visible.
I use a displayer. Or a displayer, I suppose that's what it's called.
I can hear it, but I would like to see it. Let's go for what? For what we go? We need to take one old school experiment. Famous Professor Crookes invented this. Oh, this invented. Moment, I will get Crookes invented. A what? A hole. Here's my high voltage source. Hey, come on. Light off. What do we see? Green stripe. What's inside? How it works? Vessel, evacuated vessel. One. This electrode. Another. Meet some approximately 6,000 volts. High voltage. Yeah, it's a high voltage. Under high voltage, what happens? Electron can escape, negative charge. This side is charged negative, this side is charged positive. So electrons can escape this disk and fly forward. In the way of electrons, there are two objects. Object number one is a slotted disk. To make electrons, to shape this electron flow into flat beam. This white area is a screen like this, covered with zinc sulfide. What's good with zinc sulfide? When it's bombarded by electrons, it glows with the green. And you can see the green stripe. Can you see the green stripe?
Yeah.
They can come closer. What happens? Why beam goes down?
Magnetic field is interfering with the electron.
Electron flow is a current. When current is in the magnetic field, ampere force applies up, down, maybe from this side. Oh. So, magnetic field, you can see it, deflects electrons beam. This moment I camera closer. For those who watch online. One. Light reflects. One more. Hop. Beam deflected here. Our north pole deflects. Our south pole magnet deflects my beam. Now more. Crooks equipped his vessel with two, here they are, pair of electrodes. Maybe I need the wrong point. Pair of discs. And those, yeah, electron beam. What will happen if I apply positive charge to this plate and negative here? What physics teach us about electrons? What they have for negative charge, yeah? And negative charge will be attracted by positive plane and pushed away by negative. Meaning what? Yeah, I applied positive and negative. Meaning what? Beam will go up. Yeah? We will see something like this. In opposite, if I apply plus to bottom, beam will go down. Let's see what happens. I have attached this small manual generator oscillates up and down, up and down.
Sir, is it possible to close the line above us? Because you can see the reflection in the glass out there.
Up and down, up and down. Follows my generator. Good. Here, object called cathode ray tube. This part produces electron beam, one set of deflection plate, and from this side can be visible another set of deflection plates. Special vessel. One is approximately -6 kilovolt or greater. Heating. This one is heater. Heater is thermo. If you remember physics, thermoelectron emission. Electron, yeah, they can leave hot surface, hot object. So here is beam of my electrons. I can have this one is for sharpness control. General one plate, something like this. Second set of plates. X. Wait. No, I'm drawing nonsense. If I like to draw like this, I need to draw one set, another set. This will be horizontal movement, this will be vertical movement. Plates are forming something like this. X1, X2, Y2, this one Y1. With two sets of plates, I can move beam up, down, left, right. Plus kilovolts, and of course here cover of so-called luminophores. Things sulfide may work. Where are you? Luminophores. This one, this black, is a anode. Electrons will go the plates, and this part produces electron beam. My old friend CRT-based oscilloscope. here. 1 second, I need. Here is my bead. And where is my wire? What do we see? Up, down, up, down. I'm using vertical channel. So I have amplifier, Y channel. Amplifier with adjustable gain, X channel. Now I'm using Y channel, vertical channel. Now signal is attached to horizontal X channel. Let's add something. Now it's oscillates with frequency 400 Hertz. Wait 1 second. Why? What I'm doing? I have 2 generators on my disposal, lower one and higher one. I will use signal from lower to drive horizontal and from upper to drive vertical. Oops. Now 2 generators, both with frequency 400 Hertz, are operating. One on horizontal movement and upper one, lower on horizontal, upper on vertical. What's the name of figure we observe? Something familiar? No? Lissajou. What I can do? Where is 800? Upper producing 800 Hertz, lower 400 Hertz. 800 and 400. It's called research figure. Process when in my case, two harmonic signals are used to drive electron beam. Can we say that we observe some kind of chart? Yeah, we have coordinates here. X, Y. What sets horizontal movement? First signal. And what we see on vertical? Second signal. But what do we see? What's this green figure? If it would be a chart. Charts are, let's say, y function of x. What is x in our case? X. Oh, it's a signal of generator, yeah? Of lower. And what is y? It's a signal from upper generator. So our research figure is second signal drawn as a function of first signal. Upper 300 Hz, lower 400. They both are harmonic. It was their shortest harmonic. And here we see harmonic signal of 300 Hz drawn in a space of harmonic 400 Hz signal. You see, its signal represented as a function of another signal. I can use special kind of signal, tooth saw, or signal like this. In this point, it is proportional to time. If I use such kind of signal as a driver for horizontal, I will get my y displayed as a function of time. Okay, with some kind of scale. 1 second, I will. Oh. Very nice. Moment, I will. Oh, maybe something like this. I activated internal tooth-saw generator. The only one problem. You see what it runs. Because there is a slide between observable signal frequency and internal time sweep signal. To make picture stable, synchronized circuit is needed. Here is my observable signal. It can be UT or E0. Some Z0, no problem. Voltage of synchronizer. Trigger. Special triggering circuit. One moment, I will activate it here, here, and on. Shift here. I'm changing level of triggering circuit, and you see 0 point moves. It's a moment when sleep is triggered. This is moment when the oscilloscope 0 time starts. Here you can see nice harmonic signal observed. By change of the signal slope, I can change what I can change. I can change time scale. I can change time scale for my signal. Ten times. Here. Nice signal. Yeah? Yeah. What's important? Why I'm taking research figure? Okay, this we now observe signal, it's one moment. Another important moment here. In case of research figure, we saw what? We saw signal represented not in time, but as a function of another signal, in the space of another signal. It's a trick. Theory of signals uses for its purpose. Okay, I'm lazy. Yeah, you saw signal. Questions? We have need this one. Let's see what about attendance. No. What the hell? Let's see. Something definitely went wrong. This door reader failed. Okay. This means what I will need to do it manual. Do we have Rajdeep Singh here? No. Oh, account Erdogan?
Oh, well,
Okay, but will be. And what about Bochao? Okay, absent. And who is present? Chinadeo Shinaf Mohammed Nihal. Here? No. Etadode Sharanu. Oh, here. Etadohe, I'm spelling correctly. So, Sharatz is your name. Okay, so and what about Kunat Audit? What's the correct spelling? Adit. Okay. Marking here. Prashal Rishi? No. Punchi. What? Tijan. So, okay, Tijan here and Wang? Yeah, I'm marking. Stupid. This system is stupid. I don't know why it showed no one registered.
Problem is that the system upgrade occurred about a few days ago, and everything is still adjusted.
This makes me angry. And when I'm angry, it may lead to violence. Wait, please wait. Please wait. Wait. Yeah. Recorded. Fine. Okay, I think it's okay for today. Next time I'll bring more signals. Maybe some questions?
Well, sir, I do have a question, but not related to today's topic. I'm just saying, do we have any home assignment that we need to do?
Yeah, you will. Someone with 606 in name. Hey, Mr. 606. Yeah. That's what I told when we started. I have 4 tasks. If you need to just pass this course, solve 1. If you need good mark, solve 4. They are on a learning system. You should find them. If not, I will correct if something went wrong. Yes, I have a question. Okay, bring your question here. We have online question. Question? Yeah, it's a delay in streaming platform. You can ask low delay, but this will downgrade video quality. If you agree to normal delay, you wait for some 5 seconds. Yeah. See, you have one watching. Who are you even asking about having a question? Not being rude. Yeah, you're not keeping. Even if one person watches me, now I have 2 persons exactly at this moment. I need to ask, do they have a question? If I don't like their questions, I ban them. If they ask for something what may be interesting to audience, why not? I will answer. Okay, any questions about research figures and signal definitions? And see, This scope is ordered by me. This scope made 3 years before me. But your wife and joint, can you tell what I'm teaching? I'm teaching theory of signals. If you're interested, you can go back my channel. This you can find whole course for previous year, if you like. Look for theory of signals in English. Most of records are in Latvian, but you may be interested. I recorded full set of lecture previous year, so you can look my channel just for theory of signals. You can also find course of calculus in power and energy in power engineering, better say, and set of lectures for power system protection. Oh, you're welcome. Some videos are downgraded, but some are still in good quality. To my sadness, YouTube downgrades old videos. But can take my class. Okay, I think we can finish for today. Let's see what happens next. Next we will have 2 lectures. So see you next week. Today I'm finishing.